Hello, this video is being recorded for you to help explain the hyperbola examples from your interactive notebooks. So please grab the interactive notebook and turn to page 19. Make sure you have that ready, and let's begin. We want to write an equation for a hyperbola that has foci at 2, -2 and 12, -2. And we also have the equations for the two asymptotes, y equals 3/4 x minus 29/4 and y equals -3/4 x plus 13/4. As with all other conic sections, make sure that you're using coordinate algebra to explain how we're finding these different pieces. And coordinate algebra just means use the distance formula and use the midpoint formula and talk about the relationships between the ordered pairs that are part of the conic section. For example, the center of any conic section is the midpoint of the foci. That's just characteristic of the center and the foci. That's one of the relationships that they share. And so when you're using the midpoint formula, label that. Tell me that you are using the midpoint formula because you're finding the center and you recognize that the center is the midpoint of the foci. So then we can write this as HK, H comma K, which is our center, is the same as 2 plus 12, all divided by 2 for the x-coordinate, and -2 plus -2, all divided by 2 for the y-coordinate. So now you know that your center is 7, comma -2. Very helpful because we do substitute h and k into the standard form for the hyperbola. The other thing we need to keep in mind as we're writing the equation of this hyperbola is where's the conjugate axis, where's the transverse axis, how is this hyperbola oriented. If you pay attention to the coordinates of the foci, you'll notice that the y-coordinate of each focus is the same. So because the y-coordinates are the same, we know that the horizontal axis is the transverse axis, which tells us that this is a hyperbola that is horizontal and opens left and right. One other thing that we can tell from the y-coordinates being the same, and also given the equations of the asymptotes, we pay attention to the slope. In one case, the slope is 3/4, in another case, the slope is -3/4. And those values, numerator and denominator, tell us the values of A or B. And it's important to understand which one is in the numerator and which one is in the denominator. By recognizing that we're working with the horizontal transverse axis, we can determine that the slopes of the asymptotes have the formula plus or minus B over A. So the slopes are plus or minus B over A. And then in looking at those slopes in terms of 3/4, -3/4, we now know that B is the numerator, so B is 3 and A is 4. Very helpful. The last thing we need is the correct standard form. The horizontal transverse axis tells us that the hyperbola will open left and right, which means that it's going to open in the x direction. So that means that the larger of A or B has to appear in squared form underneath the x part of the equation. And I hope I said that correctly enough for you to understand. So here's what I mean. We're going to have x minus h squared over a squared minus y minus k squared over b squared equal to 1. One of the questions that comes up a lot is, how do I know what to put in for A? How do I know what to put in for B? And the answer is twofold. First, A is always the larger of the two values, A and B. Secondly, A squared will always appear underneath the part of the formula that matches the direction in which the hyperbola will open. So in other words, because this hyperbola opens left and right, that's in an x direction that matches the x-axis in terms of that horizontal direction. And so in representing x, we'll make sure that the larger of the two appears under the x minus h squared part of the formula. So when we write our final formula, we'll just plug in hk, a, and b, and we'll have x minus 7 squared over 16, because a is 4, minus y plus 2 squared, remember to change that sign there, over 9, looks like a G, I apologize for that, over 9 equals 1. And so that's the standard form of this equation. Now you get to graph it. Yes, congratulations. As we prepare to graph this hyperbola, I've written down some things that we know. We know that the center is located at 7, -2 on the coordinate plane. The foci are located at 2, -2 and 12, -2. We have two linear asymptotes, and these are the equations for each of those. We know that the horizontal radius is 4, which means that we're going to go a distance of 4 to the left and to the right of the center of the hyperbola. And we know that the vertical distance is 3, which is the conjugate radius, which means we're going to move a distance of 3 above and below the center of the hyperbola. We are missing the vertices, but I'll talk to you about how to find those. It's a very easy thing to do once you begin to graph this. Now, one of the things I want to address is it seems to me that from looking at ticket out the doors that students have become accustomed to always setting up the axes so that the horizontal and vertical are always in the middle of the graph. So you're used to maybe doing something like this and always putting 0 in the middle, and then your graph doesn't fit, and so now you want the graph to come all the way off the graph, all the way off of the grid. We're not going to do that. What I need you to do is to think about the values that you have, how far in the positive vertical direction, negative vertical direction you need to go, and then how far in the horizontal direction, left, right, positive, negative, you need to go. One of the things that I see is that I have a focus that goes out a distance of 12 in the horizontal direction, and that's in the positive x direction. So that lets me know that my x-axis is going to use more of its positive side than its negative side. So what I do to accommodate for that is I just back up my vertical axis so that I have enough room on the x-axis. The other thing is to kind of look at where you are in terms of your y-coordinates. So my y-coordinates here are -2. According to B, I'm going to have to move a direction of 3 in that direction. So that means I'm going to need some room in the vertical direction to go -2 plus 3, which is +1 at least, and -2 minus 3, which is -5 at least in this direction. And so I think for where I am right now, this is fine. The other thing I'm going to have to pay attention to is I don't have enough room to go from 1 to 12 this way if I scale by ones, which means I'm going to have to scale by something different. And that is okay. Don't be afraid to do that. So the way I'm going to set this up is I'm going to scale by 2s. So this is 0, and this guy is 2, 4, 6, 8. That's an 8. 10, 12, 14, etc. The positive y-axis, I'm going to scale the same way. So this is going to go by 2s. 2, 4, 6, 8, etc. This is my x-axis. This is my y-axis. I need for you to label your scale and your axes. That's important so that someone looking at your graph knows exactly what you scaled by and what numbers you're coming up with. You can do a few in the negative direction as well. That's -2, -4. And here we have -2. That's a little sloppy. I'll leave that off. That's why I just tend to do it in the positive direction, and then my audience gets the idea of what I'm trying to do. So let's graph what we have so far. And we know we have a center at 7, -2, which is about here. That's our center. I know I have foci at 2, negative 2. So that's here. And also at 12, negative 2, which is here. So notice that that is a distance of 5 away on either side. Now, here's the trick to graphing a hyperbola. Use A and B to find your vertices. And actually what we're going to do is we're going to draw this wonderful box that I love. It makes me so happy because it makes things easy to do. So if I am at my radius, I know that I have to go a horizontal direction of 4 and a vertical direction of 3 in order to accommodate the axes for the hyperbola. So when I do that, if I'm at 7 and I go in a horizontal direction 4, then I'm at 11, negative 2 in the positive direction, positive x direction. And if I go back to the center at 7 and go to the left 4, then I'm at 3. Those are my vertices. They are on that transverse axis. But that's not all. If I go back to the center and move up 3 in a vertical direction, then I am at 7, positive 1. And if I go down 3 in the negative direction, so that's 2 and then 3, then I'm at 7, negative 5. Now, those points aren't as important. What is important is that we can draw a rectangle that has a width of A and a height of B, if you want to think of it that way. And so what that means is that I have this little imaginary box. It kind of looks like this. And you know, if you have a ruler, I would draw this definitely more exact. But this is the box that we're looking at. And the reason this box is so cool is because your asymptotes are the diagonals of this rectangle that's just been created. It sounds crazy, it sounds mind-blowing, but it's amazing. So first let's go back and look at these vertices. So these vertices are at, let's see, we were at 7 and we went to the right 4, so that's 11, negative 2. And then we were at 7 and went to the left 4, so that's 3, negative 2. So those are the vertices. Now, the next thing that I recommend is that you draw the asymptotes. And honestly, that is as simple as starting from the center and drawing lines through the diagonals. Like this. So these are the asymptotes. And again, if I had a ruler, I recommend you get a ruler. These would be a lot more exact. For the sake of what we're doing on the video, I'm literally turning the iPad sideways to try to get this as exact as possible. And as you can see, I'm not doing that great of a job, but that's okay. I just want to be sure that you get the idea. So let's see if I can bring this back down a little bit. There we go. That looks a little bit better. So these are your asymptotes. And remember that the graph will get very, very, very close to these asymptotes. But in a parabola, they will never touch these lines. So now what do? Now you start at each vertex and you follow the curve of the asymptotes. The hyperbola will not come inside this box, but it is going to kind of curve out like this, following those asymptotes. On the left side, you start at the vertex, don't go inside the box, but follow the curve of the asymptotes. Get closer and closer and closer, but never actually cross the asymptotes. And that's the graph of your hyperbola. I don't want to make it any more complicated than that. I think it's complicated enough as it is for you. But again, to recap, start at the center. Use the transverse and conjugate radii to create a rectangle. Draw in the asymptotes as diagonals of that rectangle. Go back to the vertex. Follow the curve of the asymptotes to draw the hyperbola. I'm going to end the video right here because it's already kind of long and I'm going to record the other part in a part 2 so that it'll compress better. So take a look at this one, look at the examples you did today in class, and practice some more, and then I'll record part 2.